So I will be going through the February-March 2022 mock exam of KGS for physics, section A, the MCQs. So question 1 says that air in a sealed syringe is slowly compressed by moving the piston. The temperature of the air stays the same. So we know that if it's being compressed, the volume is decreasing, as it says in the question, and the temperature is constant. So when the temperature is constant and the volume is decreasing, that means the pressure will always be increasing. So therefore, we can rule out answer A and B because A and B say that the pressure is decreasing. Out of C and D, either the pressure of the air increases because its molecules now hit the syringe walls more frequently, or the pressure of the air increases because its molecules now travel more quickly. However, the question states that the temperature of the air stays the same, which means that it is constant. This means that the kinetic energy does not increase, so the molecules do not move more quickly, so we can rule out option D. And the answer will be option C because if there's less volume, there will be more frequent collisions and thus the pressure will increase. Question 2 shows three containers P, Q, and R. Each container contains the same liquid. The depth of the liquid is the same in each container. Which statement about the pressure of the liquid at the bottom of each container is correct? Let's recall the formula for pressure in liquids. So P equals to rho G H. So if it says that the depth of the liquid is the same in each container, so H is obviously equal in P, Q, and R. G is a constant as it is the gravitational field strength at 10 newtons per kilogram. And rho will also be equal in P, Q, and R because it says each container contains the same liquid. So if there's water in P, water in Q, and water in R, the density of water in each container will be the same. So therefore, rho, G, and H all are equal. Therefore, the answer will be 2D because the pressure of the liquid at the base of P, Q, and R, all of them are equal. Question number 3 says that a mercury barometer is used to measure atmospheric pressure. Which distance gives a measure of the atmospheric pressure? So atmospheric pressure is measured from the surface of the liquid to the height of the liquid, which is clearly shown by B and not A because A is showing the height of the glass tube itself. Question number 4 says that a block of aluminum of mass 2 kilograms has an initial temperature of 20 degrees Celsius. It absorbs 7,300 joules of thermal energy. The specific heat capacity of aluminum is 913 joules per kg degree Celsius. The question is asking what is the final temperature of the aluminum block. So let's just write the formula of specific heat capacity. So C is equals to change in heat over mass into change in temperature. C as in specific heat capacity. Step 2, let's substitute what we already have given in the question. So specific heat capacity is given as 913 equals to change in heat is given, the heat is given as 7,300 joules divided by the mass given as 2 kilograms, and the initial temperature is given, and we have to find the final temperature. To find the difference in temperature, you do final minus initial. We do not know final, so we'll do x minus the initial, which is x minus 20. Then in step 3, we can write that 913 is equals to 7,300 divided by 2x minus 40. In step number 4, we can take the numerator, we can switch the numerator around, so the denominator around, so it'll become 2x minus 40 equals to 7,300 divided by 913. And then in step number 5, 2x minus 40 is equals to, when you divide 7,300 by 913, round it off to 3 significant figures, and you get 8.00. So this means that 2x will equal to 48 and x would equal to 24 degrees Celsius. Therefore, the answer will be C. Question number 5, the relationship between pressure as P and volume as V of a gas given as PV equals to constant. Under which conditions for the mass of a gas and for its temperature does the equation hold? So the question is saying mass and temperature. So we need to know that mass does not change. Mass is always constant. So we can rule out option A, we can rule out option B. So it will either be C and or D. The relationship between pressure and volume is inversely related, and this only happens when the temperature is constant. So therefore, the mass has to be constant and the temperature also has to be constant. So the answer will be five. For question 5, the answer will be D. Moving on to question 6, which graph shows the relationship between the pressure and the volume of a fixed mass of gas at constant temperature? For any inversely for any inverse relationship, the graph will always look like this, a decreasing slope. So the answer will be B. For question 7, a brick of weight 80 newton stands upright on the ground as shown. What is the pressure it exerts on the ground? So we know that pressure is equals to force over area. So force, we can rearrange this formula because oh, we don't need to actually do that. We can just use this formula. Pressure equals to force over area. We need to find the area as 10 multiplied. We need to find the base area, which is 10 multiplied by 5. So 10 multiplied by 5 equals to 50 centimeter squared. And then you can put it back into the original formula. So we can find the pressure as P equals to, the force is given as 80 newtons, 80 divided by 50. So pressure is equal to 1.6 Newton per centimeter squared. So the answer for 7 is D. Moving on to question 8. A fixed amount of gas is trapped inside a metal can. The temperature of the gas decreases, but the volume does not change. How does this change affect the kinetic energy of the gas molecule and the pressure inside the metal can? So one thing must remember is that the relationship between temperature and kinetic energy is like directly proportional. So that means if the temperature is decreasing, so will the kinetic energy. So if the kinetic energy decreases, we can rule out option C and option D. And now if there's less temperature and less kinetic energy, that means the movement of molecules will be slower. This means there will be less collisions inside the metal can, which means that overall the pressure will decrease. So if kinetic energy is also decreasing, that means pressure is also decreasing. So the answer for question 8 will be option A. Question 9. An underwater diver moves from the ocean to a freshwater lake. The density of water in the lake is less than in the ocean. In which position does the diver experience the smallest pressure due to water? So it said that the density of water in the lake is less. So let me just write that. In the lake is less dense and ocean is more dense. Again, let's recall the formula for pressure due to water or liquids. Pressure equals to rho GH. So let's compare option B and D, because option B and D have more depth, which means the value of H will be more. That means they will all automatically have more pressure. So we can rule out option B and option D. Option A and option C are at similar heights, so we cannot really tell which one will experience more pressure. However, the question did say that the density of water in the lake is less than the ocean. So for option A, rho will be higher, whereas for option C, rho will be lower. So the value of C will give you the smallest pressure due to water. So the answer for question 9 is C. Question 10. What is a unit for heat capacity? This is a very easy question, and the answer is joules per degree Celsius. So the answer is 10. The answer for 10 is C. Question 11. Some gas is trapped in a closed container. The gas is cooled and the volume of the container is kept constant. What happens to the gas molecules? If the gas is cooled, that means the kinetic energy is less, so they will obviously slow down. They won't collide more often because they have less energy. They won't contract and they will move slower because there's less kinetic energy. The specific heat capacity of lead is 130 joules per kg Celsius. Lead of mass 0.5 kilograms is heated from 10 degrees Celsius to 35 degrees Celsius, which calculation gives the amount of thermal energy in joules absorbed by the lead. Okay, so let's just write the formula again. C equals to change in heat, or Q, divided by mass into change in temperature. Step number 2, we substitute the values given. So replace C with 130. The heat we have to find, let's just write that as J as given in the question, divided by the mass, which is given as 0.5, and the change in temperature is from 10 to 35, so 35 minus 10 is 25, so we can just write 0.5 times 25. We can take this to the other side to find J, so in step 3 we can write that J, or the heat, would equal to 130 multiplied by 0.5 multiplied by 25. Therefore the answer will be, for question 12, the answer will be option A. Question number 13. An oil tank has a base of area 2.5 meters square and is filled with oil to a depth of 1.2 meters. The density of the oil is 800 kilograms per meter cubed. What is the force exerted on the base of the tank due to the oil? So let's find the pressure first. So the pressure would obviously be in fluids, P equals to rho GH. Therefore, we can find P is equals to 800 is given as the density, multiplied by G is always 10, as it is the gravitational field strength, multiplied by the height, which is given as 1.2. When we multiply this, we get 9,600 pascals. I know this answer is one of the options in out of A, B, C, and D. However, they did not ask for the pressure. We've only calculated the pressure. They have asked for the force exerted. So now we have to use a second formula. P is equals to force over area. Rearrange the formula to find the force. So force will equal to pressure times area. So force will equal to 9,600 multiplied by the area was given as 2.5. So the force will equal to 24,000 newtons. So the answer for question 13 will be D. Question 14 says that the diagram shows an air-filled rubber toy. A child sits on the toy and its volume decreases. The temperature of the air in the toy does not change. Temperature is constant, the volume decreases. You should already know that this means that the pressure will increase because of Boyle's law. How does the air pressure in the toy change and why? We know that the pressure will increase, so let's rule out option A and option B. Now, so out of C and D, either it will increase because the air molecules will move more quickly, or it will increase because it strikes the rubber more frequently. This is very similar to a previous question we have done. The air molecules will not move more quickly because the temperature is constant, so kinetic energy is not changing. However, there will be more frequent strikes with the rubber, or more collisions, because there is less volume. So the answer for question 14 will be D. Question number 15, the temperature of a bridge rises from 5 degrees Celsius on a cold night to 25 degrees Celsius at midday. What happens to the bridge? So we know that mass has not changed, so let's rule this out. Heavier, again, mass has not changed. So A and D are not correct. Out of B and C, either the bridge becomes more dense or its length increases. The bridge cannot become more dense because it is heating. The temperature increased by 20 degrees Celsius. So the particles are moving further apart. So it does not become more dense, it becomes less dense, and the length will increase. So the answer for question number 15 will be C. Let's move on to question number 16. The diagram shows electricity cables being put up on a warm day. The cables are left loose between the poles as shown in the diagram. Why are the cables left loose? They're being put up on a warm day and they are left loose. This is because when in winters, especially when the temperature is lower, these cables will contract and get closer together, so they have to be left loose. So 16 is A. Question number 17, which statement about the thermal expansion of solids, liquids, and gases is correct? Liquids do not expand, liquids do expand, that is wrong. Liquids expand more than gases but less than solids. We know that the gases expand the most because of their structure, so we can rule out option B. Liquids expand more than solids but less than gases. They do expand more than solids and less than gases, so C will be the correct answer. And D is not the correct answer because liquids do not expand the same amount as solids. So the answer for 17 will be C. Question number 18. An airtight container holds a fixed mass of gas. Its pressure and volume are measured on 4 occasions when the temperature is 20 degrees Celsius. Results are shown. So that means for all 4 readings, the temperature is constant. 3 sets of readings are correct, which set of reading not correct. So you have to use trial and error in this question. So use P1 V1 equals to P2 V2. Let's compare A and B first. So 120 multiplied by 38 should be equal to 100 multiplied by 48. 121 multiplied by 38 gives you 4,320 equals to, whereas this gives you 4,800. So these two are not correct, which means either A or B are incorrect. Let's compare B with C to check if B is the problem or A, because it says 3 are correct and only 1 is not correct. So let's compare B and C now. So 100 multiplied by 48 should be equal to 80 multiplied by 60. 100 multiplied by 48 gives you 4,800, and 80 multiplied by 60 gives you again 4,800. So B was not problematic. A was the incorrect answer. A was the incorrect reading, which means the answer for question number 18 will be A. Question number 19. Which row describes the forces between the molecules and the motion of the molecules in a gas? The forces between the molecules and the motion of the molecules. These are the two questions they're asking, and in a gas. Forces between the molecules for gases, they are far apart, so they are not strong, so we can rule out option A and option B. And the motion of the molecules in a gas, do they move freely or do they vibrate only? They are far apart, they move freely and spread out quickly. So the answer, so D is ruled out because they do not vibrate only, they do move freely. So the answer will be C for question number 19. Let's move on to question number 20 now. A gas occupies a volume of 2 meter cubed in a cylinder at a pressure of 240 kilopascals. Piston compresses the gas until the volume is now 0.5 meter cubed and the temperature remaining constant. This again, we will use P1 V1 equals to P2 V2. So the initial pressure was 240 kilopascals multiplied by the initial volume as 2 is equals to X, which was the new pressure, multiplied by 0.5. So 240 times 2, we get 480 is equals to 0.5x. Take 0.5 to the other side and we get x is equals to 960 kilopascals. So the answer for question number 20 will be D. Thank you for watching. I hope you understood this video.